Okay, let's move on to calculation number 4 on our gas stoichiometry lab report. Again, I'm using some student data that I collected for my calculations, and you may want to do these calculations along with me, but make sure that you're putting your own numbers in your lab calculations. Calculation 4 says determine the volume that the hydrogen would have if measured at STP, which is 760 torr, we sometimes write that as 1 atm, and 273 kelvins, which is equivalent to 0 degrees Celsius. We're going to use our measured volume, pressure, and temperature to figure this out. All right. So for starters, I'm going to take my equation, and since we're looking for the volume at STP, I'm going to solve this equation for that variable. In other words, I'm going to move the pressure at STP to the other side and the temperature at STP. And I can do that by multiplying by the reciprocal, and this will cause those terms to cancel. I should do the same over here. I like to rearrange my equation when I have variables in the equation rather than numbers. It just seems like it's a little bit easier for me to write. So in other words, to find volume at STP, we're going to need to take the temperature at STP times the pressure that we measured times the volume that we measured, and divide that by the pressure at STP and the temperature that we measured. So this calculation will tell us what our volume would have been if it had been measured at STP. Recall that we did this at lab conditions, and so we definitely had a different temperature, and our pressure also needs to be adjusted. So to determine the volume it would have had at STP, I'm going to take the temperature at STP, which is 273 kelvins, multiply that by the pressure that we measured. Recall that's going to be the pressure of the hydrogen gas by itself. And we did a little calculation in calculation 3 to find the pressure of the hydrogen gas without the water vapor added. And we got 741.1 millimeters of mercury. Again, you're using your own numbers as you're doing the calculation, but my numbers look like this. The volume that I measured, this will come from my lab data table. Looks like the volume of the gas mixture was 44.2 milliliters. This is not only the volume of the hydrogen gas that was in there, it's also the volume of the water vapor. It's the volume of the gas mixture. It's the volume of all of those. It's the amount of space that those gases were all occupying. So we're going to use 44.2 as the volume of the gas mixture. 44.2, and I'm going to write the units next to that. Those are milliliters. For the pressure at STP, we can use 1 atmosphere, or in torr we would call that 760. And I've been writing those as mmHg, so let's do that. And then finally, the temperature that we measured also will come from the data table. It looks like the temperature in my experiment was 23.4 degrees Celsius. So 23.4 degrees Celsius. I need to add 273 to turn that into a Kelvin temperature. And actually, you may not realize this, but the number we've been using, 273, is actually 273.15. If we want more precision, we could add a couple more digits to that. And since I'm trying to add up a temperature that has a number in the tenths place, I'm going to go ahead and use that full number, and then I will round it off to the tenths place when I'm done. So it looks like 296.55 kelvins. or we could round that to 296.6. And now all that's left to do is to punch in all those numbers on the calculator. It's always a good idea to make sure that units are canceling, so my kelvins should cancel, my mmHg cancel, and for my answer I'm going to get that in milliliters. So now let's throw those numbers in the calculator. I've got 273 times 741.1 times 44.2 divided by 760 divided by 296.6. So I calculate the volume at STP for the gas that we collected, 39.7 milliliters. Again, there's a bunch more digits, but I'm rounding my answer off so that it has 3 digits, calling it 39.7. Again, this is the volume of the hydrogen gas that we collected had it been collected at STP. this little conversion step shows us what it would have been under standard temperature and pressure conditions. And that's the end of calculation 4.